Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. If you are new to my channel, please do subscribe to my channel, and if you like my work, please do like my videos based on HSTR and also share among your friends. Here I am with the chapter Classification of Elements based on HSTR syllabus for chemistry, and in this class I am going to discuss this part of this chapter. That is Doberiner's Triads, Newland's Octaves, Mendeleevs and modern periodic table, and periodic trends of modern periodic table. The next part of this chapter, that is transition elements and inner transition elements and their properties, I would discuss in the next lecture. Okay. So in this lecture, I am going to discuss the red box portion. So let us start the class. Before starting the class, I want to remind you all that if you have not watched the previous class, that means I have made one class based on basic knowledge about periodic table. So you need to watch that class. After that only you have to come and watch this class. Okay, because though that part is not exactly given in the syllabus, it is very useful for any chemistry candidate who is attending HSTR. Okay, so that's why I have made that class. That will be a very nice basic introduction about periodic table. So before watching this class, you have to watch that class and then watch this class, because I am going to discuss multiple choice questions at the end of this class, which will be based on that class also. That is the class based on periodic table also. And also, if you are new to this channel, please do subscribe to this channel, and all of you, please, if you are liking my work, please do like the videos and also share these classes among your friends, CB aspirants especially, because you all are asking for paid classes, right? So if you want me to take paid classes, then I need to have strength of aspirants between at least 75 to 100. Okay. So please share these classes as much as possible, and ask your friends to join the Telegram channel also. I will give the link of the Telegram channel in the description. So tell them to join the Telegram channel, because that is one platform where we all can discuss things, and also you can talk to me personally also, because from that channel I have one group. You can enter into that group very easily, and you can talk to me personally also in that group. So let us start this class. Now this class is going to be very interesting, because it is nothing but a story of how a present day periodic table has been made. Right from starting to its root to the building it is till now, no? The modern periodic table, what we call it, how it was developed. All the stories come under this portion. Okay, so let us start with the actual history of a periodic table. Now this story starts with a German chemist named Johann Wolfgang Doberiner. What he did was, he grouped three elements with similar properties, and he called these group of three elements as a triads. Triads. Okay, triads means group of three elements. He observed that these group of three elements, or these triads, could be formed in which all of the elements had similar physical and chemical properties. Then he gave the law of triads in 1864. He told that elements can be arranged in groups of triads in which atomic mass of second element or middle element will be the arithmetic mean of the first and third element in that group of triad. Okay, I hope you are understanding. What he actually told was, there is a group of three elements. Okay, if you take the middle element, the middle element's atomic mass will be equal to average of atomic mass of first element and third element. And he also told that the difference in the atomic mass of all the elements will be constant. Means difference of atomic mass between first and second element, second and third element, it will be constant, he told. For example, lithium, sodium, potassium. You can see here that the atomic mass is 9, 23, 39. The difference will be same if you see the difference between each of the atomic mass of these elements. Like that only beryllium, magnesium and calcium is there. Here we can calculate and see properly. I have these three elements, lithium, sodium and potassium. I have the atomic masses 6.94, 22.99 and 39.1. These are the elements belonging to group 1. Okay. Now, if I take the average, that means I want to find the atomic mass of sodium now. For that, I will take average of first element, which is lithium, and third element, which is potassium. Nearly 6.94 is equal to 7, right? And 39.1 is nearly equal to 39, right? So 7 plus 39 by 2 will give us 23, which is nearly equal to 22.99, which is the atomic mass of sodium. So here the arithmetic mean of masses of potassium and lithium is corresponding to 23, which is almost equal to atomic mass of sodium. Like that only if we take group 2 elements, calcium, strontium and barium, and I do the calculations, I will find that the strontium atomic mass is the arithmetic mean of other two elements, that is calcium and barium. Like that only chlorine, bromine and iodine, which are the halogens, the group 17 elements. For this also, if I want to find this atomic mass and find whether these three elements are Doberiner's triads or no, I can see that the atomic mass of bromine is also approximately same. Now in the first case, the mean of masses of barium and calcium corresponded to 88, which was approximately equal to the atomic mass of strontium. And in the second case also, the mean value of atomic masses of chlorine and iodine is approximately same as that of bromine. Okay. In the same manner, Doberiner gave few more groups. Totally, he gave 5 groups. These 5 groups or triads are famously known as Doberiner's triads. So, what are the other two? We have seen for lithium, potassium and sodium. We have seen for calcium, strontium and barium. Other group is phosphorus, arsenic and antimony. And next is sulfur, selenium and tellurium. And next though we saw chlorine, bromine and iodine. Now, one question was asked in 2015 HSTR chemistry question paper. The question was this: identify the Doberiner's triads. Such a easy question, right? If you don't know anything about Doberiner's triad, you can never answer this question. If you know this story, then you can easily answer the question. The answer to this question is lithium, sodium, potassium. Option number 4. It will be the correct answer. Okay. Though Doberiner was successful till some point, he gave triads following his whatever vision he had. Still, there were limitations of Doberiner's triads. Firstly was that the newly discovered elements, they did not fit into these triads. Actually, he failed to arrange all of the known elements at that time in the form of triads, which had similar chemical properties. And Doberiner, he could only find 5 triads at that time. Only 5 triads were identified. And the law which was given by Doberiner, it was not holding good for very low mass elements or for very high mass elements. For example, if you take fluorine, chlorine and bromine, atomic mass of chlorine is not a arithmetic mean of atomic mass of fluorine and bromine. If you want, you can calculate and see. Atomic mass of fluorine is 19, chlorine is 35.4 and bromine is 79.9. If we want to find the criteria whether these 3 are Doberiner's triads or not, we do the average, right? We find the arithmetic mean. So if you find it, you can see that we are getting the chlorine's atomic mass to be equal to 49.5, which is not true because chlorine's atomic mass is 35.4. So here Doberiner's triads fail. So periodic table formation could not be taken ahead with the Doberiner's theory. Next in 1864 came the Newland's law of octaves. What did Newland do was he arranged the elements in increasing order based on their atomic masses, and he observed that every eighth element had similar properties with the first element. Okay. Like we have this sa re ga ma pa dha ni sa, no, the musical notes we have, no. He compared the musical notes to this periodic table. In the series of 8 musical notes, after a certain interval, the note will get repeated itself, right? Like sa re ga ma pa dha ni sa. Again you have sa re ga ma pa dha ni sa. Again you have sa re ga ma pa dha ni sa, right? Like that only he told that the elements in periodic table will also be repeating. On the basis of this observation, Newland's law of octaves was formulated. He was a British person and he gave this list of octaves. Like we have sa re ga ma pa dha ni sa, no. That type they have some musical notes in foreign. I don't know whether if it is France or British, I don't know the country exactly. But this is very famous, you must be knowing also. Do re mi fa sol la si. Like sa re ga ma pa dha ni sa. Like that he gave a group of 8 elements. So this was the periodic table given by Newland. So according to Newland's law of octaves, the statement was that every 8th element has similar properties when the elements are arranged in increasing order of their atomic masses. Okay, you should carefully understand what I am trying to tell. He told that elements are arranged in increasing order of their atomic masses. Okay. So if you have elements arranged like this, then every 8th element would resemble the first element. Okay. Then again, if you start from lithium, from there again 8th element, that would resemble lithium. Again you start from beryllium, from there you count 8 elements, then the 8th element will resemble beryllium. That is what Newland told. But then Newland's law of octaves was discarded because it failed to arrange larger elements. That means elements with a higher atomic number. Basically, here what happened was elements beyond calcium, they could not be arranged as law of octaves. That's why this law was also discarded. Then came the Mendeleevs periodic table. Actually, many periodic tables were made, but most important one was this Mendeleevs periodic table. Elements were arranged on the basis of fundamental property, atomic mass and chemical properties. These were the basis where the elements were arranged in the periodic table. Mendeleevs periodic table, it consisted of 7 periods, means the horizontal rows, and 9 groups, means the vertical columns. See, all these points are very important, friends. They can ask any point as a multiple choice question in the examination, because we have seen how simple the Doberiner's triads were asked, right? So it is very easy. So if you have some basic knowledge, then you can answer that type of questions, right? Okay. So Mendeleev's periodic table consisted of 7 periods and 9 groups. The criteria used by Mendeleev in creating this periodic table was that first, as I told you, physical and chemical properties of the elements, and then the atomic masses were taken in increasing order. Then he arranged the elements such that elements with similar properties fell into the same groups or same vertical columns of the periodic table, and then he observed that elements were arranged in the increasing order of atomic mass, and there was the periodic occurrence of elements with similar properties. According to his observation, a periodic law was stated by him, which told that the properties of elements are the periodic function of their atomic masses. So what does Mendeleev's periodic law say? It says that the properties of elements are the periodic function of their atomic masses. Now this one we can say was a benchmark in the history of periodic table, because this periodic table, it had many merits and achievements. Like for example, Mendeleev predicted that the atomic mass and properties of elements even before they were discovered. Still they were yet to be discovered, but Mendeleev predicted based on his periodic law, he predicted elements. And some gaps were left for undiscovered elements, like gallium is there, scandium is there, germanium is there. Those gaps were left, and before their discovery only, they were named as Eka boron, Eka aluminium, Eka silicon, as they were just below boron, aluminium and silicon in that respective subgroups. Okay, so Eka boron was later named as scandium, Eka aluminium was later named as gallium, and Eka silicon was later named as germanium. Okay, so these are all very important points, because questions have been directly asked based on this. And also he accommodated noble gases when they were discovered without disturbing the original arrangement of the periodic table. But there were few demerits also, like position of hydrogen was not fixed. He could not locate the hydrogen in the periodic table, in that Mendeleevs periodic table. Then some anomalous pair of elements were there. Actually the atomic mass should increase, right? But that could not happen. Certain elements of highest atomic mass, they preceded those with the lower atomic mass. Increase in atomic mass, it was not regular while moving from one element to another element in Mendeleev's periodic table. Another important demerit of Mendeleev's periodic table is that Mendeleev could not place isotopes. He could not give place to isotopes. What are isotopes? Isotopes are atoms having different atomic masses with same atomic number, right? So he could not give place to those isotopes, and also position of rare earths and actinides could not be justified in Mendeleev's periodic table. Now all these problems were overcome by what we call now as a modern periodic table. This was developed after the periodic law, and periodic table was given by Mendeleev. After that, the next came the modern periodic table. The development of various atomic models and advances in quantum theory, it revealed that the atomic number is the most basic property of a chemical element. Till now, till Mendeleev, all thought that atomic mass is the basic property. But when we came to modern periodic table, we understood that the atomic number is the most basic property of a chemical element. Modern periodic law told that the properties of elements are periodic functions of their atomic number. So this you should know. What did Mendeleev say? Properties of elements are periodic functions of atomic masses. But what does modern periodic table say? It says that the properties of elements are periodic functions of their atomic number. So this is the modern periodic table. It consists of 118 elements, and it has 18 groups and 7 periods. Okay. Now what are the characteristics of modern periodic table? Elements are arranged according to increased atomic number. This is the main and first characteristic of modern periodic table. Then elements having similar properties are kept in the same group. There is a interrelation between electronic configuration and atomic number. All this we have told in that class of periodic table, right? The elements are arranged in 7 horizontal rows called periods and 18 vertical columns called groups. Now this is our modern periodic table with 18 groups and 7 periods. A group, it is a column on the periodic table, and elements have same number of valence electrons. Okay, means same number of valence electrons in one group. Then period is a row on the periodic table, and elements have same number of electron shells in one particular period. Okay, this is how the modern periodic table is arranged. Now we can conclude easily that the main difference between Mendeleev's periodic table and modern periodic table is that elements are arranged in order of increasing atomic masses in Mendeleev's periodic table, whereas elements are arranged in order of increasing atomic numbers in modern periodic table. And the similarity is that both type of periodic tables had 7 periods only. But there were only 8 groups in Mendeleevs periodic table and there are 18 groups in modern periodic table. Okay. Now what type of question was asked in HSTR 2015 based on this part is this. In fact, this question only has been twisted and asked in another question paper of GPSTR. Okay. Yes. What I am telling is GPSTR. So, you should not underestimate a GPSTR question paper also. See what is the question. Question number 37 is from HSTR 2015 question paper and question number 50 is one previous year GPSTR question paper. The question is, gallium was named by Dmitry Mendeleev as, of course it was named as Eka aluminium. Same type of question in a twisted manner was asked in GPSTR. Eka aluminium predicted Mendeleev later called as, it was gallium. Okay, so gallium's name is Eka aluminium or Eka aluminium's name is gallium. So that's why I told you that every point in this class is very, very important. Okay. When the elements are arranged in the modern periodic table in order of increasing atomic number, there are repetitions of similar properties of elements, right? These elements, they are placed in a group and they are separated by certain definite gap of atomic number. Now, this is known as periodicity of an element. So, periodicity is nothing but a regular periodic variation of properties of elements with atomic number and position in the periodic table. Now keeping this in mind, what are the periodic trends? On what basis we are telling that there is a periodicity among the elements in a periodic table? For that we have periodic trends in a modern periodic table. They are the specific patterns that are present in periodic table that illustrate different aspects of certain element. And a few major periodic trends are atomic radius, electronegativity, ionization energy, electron affinity and metallic character. Now these are all the periodic trends which show that there is a periodicity among elements in a periodic table. Let us start with the first one, atomic radius. What is a atomic radius? Atomic radius is the distance from the center of the nucleus to the last shell of electrons. You can see here in this picture, the distance from the center of the nucleus to the last shell of electrons. Now in a periodic table, down the group, atom gets larger as number of electronic shells will increase. And across a period, size of an atom will decrease from left to right? So, atomic radius will also decrease from left to right as you go across a period. And with this we can say that francium has the largest atomic radius in the periodic table while helium has the lowest atomic radius. Okay, so francium is having the largest atomic radius and helium is having the lowest atomic radius. This can be asked as a multiple choice question in the examination. Okay. Now let's talk about the next trend, which is electronegativity. What is electronegativity? It is nothing but the ability of an element to attract the bonding pair of electrons towards itself. The atoms which have high electronegativity, they attract more electrons and they form chemical bonds. Whereas the atoms with low electronegativity, they can easily lose their electrons. Means the electrons which are in the outermost shell, no, they can easily lose their electrons. Electronegativity increases from left to right in a period and it will decrease down the group. Also, fluorine is the most electronegative element in the periodic table. Okay, this is a very important point. Now we can see the same trend here in the periodic table. As I already told you, electronegativity, it increases across the period and it decreases down the group. Okay. Now let's talk about ionization energy. This is also known as ionization enthalpy of elements, and it is defined as amount of energy required by an isolated gaseous atom to lose an electron in its ground state. Ground state means it is such a state of an atom where it will have the minimum energy or the lowest amount of energy is present at that state for that atom. Okay. Now ionization energy or ionization enthalpy, it is nothing but the amount of energy needed to lose one electron in its ground state. Okay. Now the ionization energy depends upon two important factors. One is the size of the atom. The other one is the nuclear charge. Okay. Size of the atom and nuclear charge. Now why we say that the ionization energy depends upon size of atom and nuclear charge? The reason is that as we move down in the group in a periodic table, the atomic number increases, right? So atomic number is increasing means number of shells is also increasing in that atom. That means the size of the atom is increasing. Whereas outermost electrons are there, no, they become more far from the nucleus. That's why removing the electron will become very easy from that outermost shell of the atom. So in that situation, atom can easily lose the electron which is far away from the nucleus. That means the bonding between the nucleus and the electron in that outermost shell, it will become very less, right? So the amount of energy required to lose that electron will also be very much lesser. So you can say that the ionization energy is inversely proportional to size of the atom. The more bigger the atom will be, the atom will need very less energy to get rid of that electron or to lose that electron. Okay. Now the ionization of energy, it increases across a period, we are telling. No. Why? Because the size of the atoms across a period, it will be decreasing, right? So the force of attraction between nucleus and electrons, it will increase, and hence more energy is required to remove a electron from the valence shell. So we told that the ionization energy is decreasing down the group and it is increasing across the period. Okay. Now let's talk about the electron affinity. Electron affinity is nothing but the amount of energy liberated when one electron is added to a neutral atom to form a negatively charged ion. Okay, it is same as that of ionization energy. If you see from that perspective, no, see the amount of energy required to remove one electron and the amount of energy required to put one electron back, it should be same, right? So that's why I say that the electron affinity is nothing but the ionization energy. But there we were telling that it was the amount of energy required to lose one electron, and this is the amount of energy liberated when an electron is added to the neutral atom. Okay. So because of the same energy, I mean the energy is the same thing right here. So we can say that this also depends upon the same two factors, that is the size of an atom and nuclear charge. Okay. And electron affinity also should increase across the period in a periodic table and it should decrease down the group. Correct? Now moving from left to right across a period, atoms become smaller and smaller as atomic number increases. Now this will cause the electron to move closer to the nucleus, thus increasing the electron affinity, and that's why electron affinity will decrease down the group and it will increase across the period. Okay, there we were telling that the atom is becoming bigger. Here we are telling that the atom is becoming smaller, but in both scenarios also the energy liberated or the energy required is same. Okay, so the trend will also be same. Now let's talk about metallic character. What is metallic character? It is nothing but the easiness of an atom in losing its electron. How much easily the atom can lose its electron is the metallic character of that atom. Metallic character of an element, it will decrease across a period because number of electrons and protons in an atom increases, and this causes an increase in nuclear force on electrons, and so losing electrons becomes very much difficult. Okay. Metallic character will increase down the group, and this happens because while moving down the group, atomic radius increases. If atomic radius is increasing means it is easy for an atom to lose the electron. Correct? So if you see the trend in the periodic table, the metallic character, it will decrease across the period and it will increase down the group. Okay? Now overall summary, you can see that the ionization energy and electronegativity is increasing across the period and atomic size is decreasing across the period. Whereas electronegativity and ionization energy is decreasing down the group and atomic size will be increasing down the group. Okay? Now this is the periodic table, typical picture of a periodic table. You need to learn all this. Okay? In the previous class of basics of periodic table also I have told you that it is very important for you all to understand all these periods and groups and how they are divided and on what basis the periodic table is divided. And you all need to understand what are alkali metals, alkaline earth metals, transition metals, non-metals, halogens, noble gases. Okay? All these things. So this was all about this part of a portion from classification of elements. Now let us discuss few multiple choice questions. Okay, the most expected and important multiple choice questions. The first question is, name the elements which have the smallest and the largest atoms. So we have a table here. In this table, group 1 elements are given and their atomic radius is also given. So you can see that as the atomic radius will be increasing, it means that the atom is larger. If the atomic radius is small, then the atom is smaller, correct? So according to the table, the atomic radius is higher for cesium, right? Cs. That means it should have largest atom, and lithium is smallest, right? So it should have the smallest atom. So the answer should be lithium and cesium. So lithium is having smallest atom and cesium is having the largest atom. Next question. The correct order of atomic radii is. Now for this we need to know the atomic numbers. Okay. If we know the atomic numbers, we can arrange the elements in a proper order and then we can know the correct order of atomic radii. Actually, one more thing you can remember is that the atomic radii decreases as we go from left to right of the period, right? As we move from left to right of the period, the atomic radii decreases. That means the fluorine will come first, right? So fluorine should have the smallest atomic radii. Then should be lithium, then should be sodium, and then should be potassium. So option 3 should be the correct answer. Okay, option C should be the correct answer. Next question. The smallest sized ion among the following is. Actually, this question number 38 is from HSTR 2015 question paper. Okay. So the question is the smallest sized ion among the following is. Now here there is one small trick. The trick is that if the element is having more nuclear charge, it means that the element will have the smallest size. More nuclear charge means the electron will be nearer to the nucleus, right? Correct? See, or else you can think in another manner also. If there is an atom or there is an ion with a negative charge, it means that it has gained electrons, right? So if it will gain electron means its atomic size will increase because electrons will occupy the shells, right? So the shell may increase there. So the radius may increase for that particular ion. Or if the ion is having positive charge, it means that it has lost electrons, right? So if it has lost electrons means number of shells would have reduced and its atomic size also would have reduced. Okay, you can think like that also, or you can simply think in this way also, that if there is a nuclear charge, more nuclear charge means that the electron is very much near to the nucleus. That means the atomic size is very much less. Correct? Now among the given 4 options here, aluminium is the one which is having a more charge, right? 3+. It means it is having less number of electrons. It means its atomic size will be smallest. Okay, so option 4 will be the correct answer here. Next, question number 3. The vertical columns in the periodic table are termed as, of course, they are groups. Next question. The element with atomic number 26 will be found in group. Which group will be there? This will be 8, because if you write electronic configuration, you will understand that for this particular element with atomic number 26, you are having valence electrons as 8. See, the outermost shell contains 6 and 2 electrons, means 6 plus 2 is 8 electrons, right? Now, in the previous class of basics of periodic table, we learnt that number of valence electrons is nothing but equal to the group number to which that element belongs, correct? Now, the group of this element will be 8 because the valence electrons is 8 here. Okay, so option B will be the correct answer. Next, question number 5. The elements with atomic numbers 9, 17, 35, 53, 85. These are all halogens. Group 17 elements, no? These are all halogens. Next question. The most electronegative element in the periodic table is, of course, I already told you, right? It is a fluorine. Option D will be the correct answer. See, all these questions, they are based on basics of periodic table class. That is the previous class. That's why I told you, please watch that class. Then only you should watch this class. Okay. Next, question number 7. The elements of group 16 are called. Actually, elements of group 17, we called them halogens. No, elements of group 16, they are also having one name given to that family. They are chalcogens. Option B. Okay, group 16 is chalcogens. Group 17 is halogens. You have to remember. Okay, you should remember the group names. I mean the numbers, even for noble gases and alkali metals also. Okay. Next, question number 18. The question is, ionization energy of sodium is the same as that of. Now, the answer to this is blindly I will take the answer. It is electron affinity of sodium. Why? Because ionization energy is the amount of energy required for the atom to lose the electron. Electron affinity is the amount of energy liberated when that electron is added in that atom. In both cases also, energy required will be same, right? Either the electron is lost or the electron is added up. The energy required will be same. That's why the answer will be electron affinity of sodium. That is one thing. Another thing is, because of the same reason, both these have same periodic trend also. Ionization energy and electron affinity, they have same periodic trend also. Okay. So, option D will be the correct answer. Okay friends, this was all about this part of classification of elements. I really hope that this class helps you, and please do like, share and subscribe, and also join the Telegram channel if you have not joined still, and also share as much as possible among the CB aspirants. Okay, only this is one way with which I can decide to take the paid classes. Okay, because I need minimum 75 aspirants to start the paid classes, right? So for that, what we have to do, we have to share more and more among our CB aspirants. Okay, thank you. Bye.